We're AutoCAD 2019, and this is our Sundial project, the phone dial.
Okay, so one of our design functions is the fact that we want the sundial to be foldable. And so what we've designed is a way to take the gnomon down from the dial plate and put it in a little compartment here, which you can then take out. And this folds back over that, and you can then put the gnomon back onto the dial plate like that. And yeah.
One of our design functions is to use adhesive to stick our sundial in the back of the phone.
To meet our second design objective, which was affordability, we had to kind of monitor how much we were spending on each piece of the project. Our total came out to be $8.19. $3 of the dollars were spent on the material you see here, which is used to hold the gnomon in place. Another $5 was spent towards the laser cutting for the dial or the sundial itself. And then the last 19 cents was spent on hardware, so screws and washers. Per unit, it would actually take about $5-ish to make. This material is really cheap, to the point where it's almost negligible. We bought like an entire roll for about $3. So really the only cost comes down to the laser cutting. And so when it's about $5 per unit, we were planning on selling it for about $6. And yeah, that should give us a good profit.
Hey, you know what time it is?
Yeah, wait a second. So it's 6 o'clock.
Thank you.
You're welcome.
$2:37, and our sundial is reading about 2:47. And once again, using the equation of time, we know that it should be 10 minutes fast. I think that's pretty accurate.
I will show how can we overcome the constraint. This sundial has to be small, so the width is 5 centimeters, the length is 6 centimeters, and the height is approximately 2 millimeters.
Okay. The sundial is made out of really 3 or 4 materials. The dial plate itself is wood, and the holder for the gnomon is a magnet. The screw and the washer, which actually isn't on here, is made out of metal, and the base and the gnomon are both 3D printed plastic. There's also adhesive, which holds the magnet here, and adhesive on the back of the plate, which allows it to stick to the back of the phone.
Our sundial is specifically set up for a latitude of 42 degrees, which is the latitude of Boston. To align it with geographical north, you would use the compass on your phone or any compass that you have on hand. Most people don't have a compass on hand, so I would recommend using the compass on your phone. The hour lines are pretty easy to read. The numbers tell you what hour it is. On the left of the 12 noon right here is all the AMs, and then on the right is all the PMs, and then in between each hour are 15-minute marks. So we have 5:15, 5:30, 5:45, and then 6, and then it's like that all the way around. To convert the solar time to clock time using the equation of time, we included the plot for the equation of time right on the back of the sundial so that it's easy to see whenever you are using it. For example, if I was using it on the first day of, say, August, I would just go to August 1st, go up, and then I would say, okay, it's 6 minutes, the watch is faster, which means that the sundial is slower. Therefore, any time that the sundial tells on August 1st would be 6 minutes slower than what it actually is. We added the equation of time right on the back of the sundial because we figured it would be easier for people to read. It makes it more convenient instead of having to look it up every single time. And when you're using it, all you have to do is turn it around, and there it is, right for you to read. The dial furniture includes the dial plate, which has a little slot for the gnomon to fit in, like that. And then we have the actual sundial. The actual sundial is screwed to the dial plate so that it can swerve around. One of the most important aspects of the horizontal sundial is how to determine the angles of each hour line, because they're all not they're not equidistant from each other. So in order to determine the angles that each hour line makes, we have to look at an equation, which is tan of theta is equal to the sine of beta times tangent of lambda. So lambda in this equation is equal to 15 times alpha, and the value of alpha is positive or negative depending on the location, in accordance with noon meridian. So for example, if it's after noon, then it would be positive, and then if it's before noon, then it would be negative. Beta in this equation is equal to the local latitude of wherever you are, and for our sundial, that is the latitude of Boston, which is 42 degrees. So all we have to do is set up the equation as if we were solving for what tangent of the angle that we're looking for is. So we plug in beta, which is 42 degrees, which is when we find the sine of that, and then we multiply it by tangent of 15 times alpha. And if we were going to say we use like 4 p.m., then we'd say that's 4 afternoon, so it'd be plus 4. So 15 times 4 would be 60. And then we find the tangent of that, and then that would be equal to the tangent of theta, but we are not finding the tangent of theta, we are finding theta, so we have to find the inverse of tangent, and that would be the angle that the hour line would make with noon. 7:35 a.m. and I am testing the sundial. And to read our sundial, you need to have the shadow long enough so that it has this point over here, which is created from the shadow of the gnomon, as you can tell. So at 7:35, well, this is positioned at geographical north, so up there would be geographical north. All you have to do to read it is just go to the end of the top of the gnomon, follow your way back, and it should read about 7 o'clock. And due to longitudinal correction, which is 16 minutes, and the equation of time, which is today on December 5th, about 9.5 minutes, there should be a difference of about 25 minutes. And since it is currently about 7:30, if we subtract 25 minutes, then it should be about what our sundial says. As you can tell again by our sundial reading, if you start from the point and go all the way back, it says that it is about 8:15, and currently it is actually 7:50. And so according to longitudinal correction, which is 16 minutes, and the equation of time, which is about 9 to 10 minutes, we should subtract 25 minutes and we get 7:50.